Hi, welcome to another Level 3 Probability Concepts video. We're going to chat about independent events. Events are independent if the occurrence of one event makes no difference or does not have a dependence on another event. If events are independent, then the probability of A intersect B is equal to the probability of A times the probability of B. For example, a type of phone and the gender of a person are likely to be independent events. But the colour of the phone case and the gender of the person are possibly more likely to be dependent events. I still think we have the silly tradition where certain genders get given or are supposed to like certain colours. Bit weird. All right, straight into example 1. The probability a student takes level 3 statistics at a particular school is 0.42. The probability a student takes level 3 biology at the same school is 0.36. And the probability a student takes both of them at the same school is 0.12. Are these events independent or not? So the probability statistics 0.42, probability of biology 0.36, and the probability of S intersect B is 0.12. If they are independent events, then P of S times P of B is equal to P S intersect B. So let's work out what P of S times P of B is. So 0.42 times 0.36, that gives us 0.1512. And we can quickly check to see it's not the same as P of S intersect B. So here's our argument. Because they're not equal, we are going to basically say these events are not independent. Now, not independent actually means there's dependence on one event on the other. And we'd expect that because probably if you're taking level 3 biology, you're probably taking level 3 statistics because both of these are required at the tertiary level as you progress. All right, here's example 2. The table shows the outcomes of an experiment in which a coin was flipped and a die was rolled 60 times each. So we're flipping a coin and rolling a die at the same time, and that's one trial. In each trial, we recorded whether we got a head or no head and whether we got a 6 or no 6. Are these two events independent of each other? Well, we had 98 heads come up and 33 sixes. And we had 16 times when we rolled and flipped the coin and rolled the die and had a 6 and a head come up. All right, if they are independent events, then P of H times P of S, it must equal P of H intersect S. So let's work out the probability of head times the probability of a 6. So that's 98 over 200 times 33 over 200. And that gives us 0.08085. Now we can read off the table the probability of head intersect S. That's 16 chances out of 200. And converting that to a decimal is 0.08. Now these numbers are so close that I'm going to call them equal. So this is my argument because they are approximately close or very close together, therefore these events are independent. And I'd expect that because there shouldn't be any dependence on what the coin does and what the dice does. But here's our last example. For a particular experiment, P of A is 0.42 and P of B is 0.25 and P of A given B is 0.06. Determine if the events A and B are independent of each other. So we know if they're independent, then the P of A times P of B is the probability of A intersect B. We don't have this information in our information at the start. We do have this information. So we can use our conditional probability formula to work out P of A intersect B. So we're going to replace probability of A given B to be 0.06, and we're going to replace probability of B to be 0.25, and we're going to multiply these two together to get the probability of A intersect B to give us 0.015. So now we do have that information. Let's carry on with our proof. The probability of A times the probability of B is 0.42 times 0.25, which gives us 0.105. And now we can check to see if we've got independence or not. We can see that these two are not equal. And if they're not equal, therefore these events are not independent. Therefore, there must be some dependence on event A and event B of some kind. All right, thanks so much for watching the video.